Hey, what's up, you guys? I told you I was gonna make this probably tomorrow morning, but today's Friday and it's 3:16 p.m. So like right after school. I'm making this for you guys just in case you non-procrastinators want to watch this video. So here we go. No side talk, no side chatter whatsoever today. Okay, hopefully. All right, let's start with ions. So ions is going to be our last topic of this unit. And so as you can see over here, I am going to give you a list of polyatomic ions. Poly meaning many, right? Many atoms, ions. So ions that have many atoms inside them, right? So I'm going to give you a list after the test, and you're going to have to memorize these before our third unit. So you have to memorize it within our second, while we're doing our second unit, and then we'll have a quiz on it at the beginning of our third unit. Really important stuff. So let's explore. So we did isotopes, and we know that isotopes have a different number of neutrons, hence different atomic masses. So now we're going to talk about ions. Okay, so ions and isotopes kind of belong, they don't belong in the same category, right? They mean completely different things, but they are similar in that, like how isotopes are atoms of the same elements that differ in the number of neutrons, elements or ions differ in the number of uh, charges or different charges. Okay, and I was actually gonna give you the answer. I wasn't supposed to, but anyways, different charges. And so, how do you think? Right, and I was supposed to let you guys discuss, so you can pretend to discuss with your imaginary friend. Okay, so if you thought, hey, am I going to change the number of protons, right, the atomic number? That's wrong because if you change the atomic number, you're changing the element, right? You can't do that. So the only thing left to change, right, are electrons. We can change neutrons, but those are isotopes. We're talking about ions. So we can change electrons. Okay, we know protons are positively charged and electrons are negatively charged, because Ernest Rutherford, no, not Rutherford, Thomson discovered electrons, right? His plum pudding model. So we know that they're negative. So we can alter charges by either taking, removing, or gaining electrons. Okay. All right. Because electrons are negative, if we add electrons to an element, we are making that element more negative. So we're having a more negative ion. And the flip side is if you take away electrons from any single element, we are making it more positive. So we are adding positive charges. Okay, so we can never add protons. Remember that. We can never add positive charges because that will change the actual chemical makeup. We can only add or subtract electrons. Okay. Now we call an ion that's positive a cation. Okay, this the easiest way to remember is just to add this positive sign, or when you see the T, think about positive, right? Cation, positive, and negative ion is called an anion. Okay, um, this means that if I have any sort of element, right, an atom, and we were to, as you can see from positive, if we were to take away electrons, so it has fewer electrons than it normally should have when it's neutral, it's a cation. And if it has more electrons than it should have when it's in its neutral state, we call this an anion. All right, so this question got kind of cut off. So why do you think having ions is important? So I'm not just giving you this information just randomly, right? For isotopes, we're eventually going to talk about nuclear chemistry, hence that's important. And there's a lot of uses for isotopes. For ions, right? Ions are very important because you can think about it, right? What do positive and negative charges remind you of? Okay, that's enough. Bonds, right? I'm glad I made this video because I can't do cheesy things. But well, where was I at? Bonds, yes. Just like how a magnet, right? The positive side attracts the negative side pole. Um, the same with bonds, right? If we have a positive ion, it really wants to attract a negative ion because right now we're at an ion state where it wants either more electrons or fewer electrons. So by bonding with another ion that's the opposite, right? They're both gonna bond and eventually become neutral since they're happy. Okay, but the strong attraction they form creates strong bonds. So later on, when we talk about ionic bonds, which are ions coming together, ionic bonds are very strong compared to another type of bond we'll talk about, which are called covalent bonds. Okay. Oh, it got cut off again. Anyways, on the periodic table, I'm reading the top. On the periodic table, the neutral lithium element has 3 protons, 3 electrons, and 4 neutrons. Okay, that makes sense. 3 protons and 3 electrons, it cancels out, so it's neutral, right? And the common ion for lithium is lithium plus, meaning lithium 1 plus, right? If it's 1, then if it's -1 or +1, we don't usually just designate the 1, right? It's just a plus, right? This positive ion is showing that it's a cation, right? So remember, we can only take away or accept electron, or we can only take away or give electrons. Okay, so if we have a lithium ion, right, lithium plus like this, how many protons, electrons, and neutrons does it have? Well, we know the proton number can't change, so it's still 3. But since it's a positive ion, like would you rather have, or would you think it's fewer electrons or more electrons? Yeah, it is fewer electrons because we have 3 positive, so let's put 3 plus like that. Actually, you can't even see this, but 3 plus. And if I only have 2 electrons, that's 2 minus. So we have one more positive charge as opposed to or compared to the 2 electrons. Hence, we have a lithium 1 plus. Okay. The neutron number is the same, right? Ions, we're not talking about isotopes, we're talking about ions. So that's 4. Okay. Now, for chlorine, we have atomic number 17, okay? And for the neutral chlorine, we have 17 protons and 17 electrons. But for the chlorine anion, right, a negative ion, we have 17 protons like normal, but we have 18 electrons because it's a negative charge. All right, now just a brief overview of the different types of charges or the different types of ions elements would like to form. The most common, okay? Like, I guess you can call it the most stable ion, even though ions are not as stable as neutral. But just a general common ion that these elements will form. There is a pattern, right? Depending on groups, we didn't talk about the periodic table at all, but we can still kind of differentiate these patterns. So this group 1A, or the first column in the periodic table, generally want to form 1 plus ions, okay? Meaning they want to give away an electron, generally, okay? The second group is +2, so they generally want to give away 2 electrons to be happy. When we talk about bonding later on, when we do our bonding unit, it is going to make more sense why this column wants to give away 1 electron, whereas this column wants to give away 2. All these middle elements over here before we go to group 3A from boron, these guys are called transition metals. Okay, generally these ions are going to be 2 plus, but there are exceptions. For instance, zinc is always 1 plus. We're going to get to this when we go into naming, okay, naming chemical compounds. This third group over here, group 3A, starting from boron, generally wants to give away 3 electrons, so it's a +3 ion. And I'm not saying that boron has a +3 charge at all times. The neutral boron doesn't, but when it does want to become an ion, it generally wants to give away electrons rather than take. This group over here, group 4, is a little tricky, right? Sometimes it wants to give away 4, sometimes it wants to accept 4. It really depends on the situation, which we'll get into later. This group over here, I guess I don't need to repeat all this, but starting from here, these guys want to take 3, take 3 electrons generally. So if they're gaining more electrons, then it's going to want to have a negative charge. This group over here, oxygen, generally wants to accept 2 electrons, and this second to last group wants to gain 1 electron, So if you guys, we're gonna talk about bonding later, but you can kind of see that maybe this group really likes to bond with this group. This guy wants to give one, these guys wants to take one. So and in chemistry they do like to bond to each other. Although we can bond a whole bunch of elements, but these in particular do like to give away. You notice that hydrogen is a -1 over here. It's because hydrogen can act as both +1 and -1. We'll talk about properties later. And this last column over here, these are called noble gases. They don't want to give away electrons. They don't want to take away electrons. So these guys in nature, you'll find alone without any other atom bonded to it. Now we can force in the laboratory, force them to bond with other elements, but it's very, very, very unstable. All right, so let's do some practice problems. Calculate the protons, electrons, and neutrons for the following atoms. So we have sulfur over here. Sulfur is atomic number 16. Yeah, 16, I believe. So 16 protons. It's neutral, no charges, so 16 electrons and neutrons. Oh, I didn't memorize the mass numbers. Let me actually look that up for you guys. Hold on. I didn't memorize mass numbers. Although I know sulfur, I don't know some of the other ones on top of my head. Oh, sorry. Periodic table. When you need a periodic table, it's not showing. You guys, time is gonna run out. I apologize for this. Why isn't my phone? It's like the moment you need it. You know what? Pause. All right, I apologize heavily. Okay, wow, it's already 12 minutes. Anyways, neutrons. Sulfur's atomic mass I have it down right here. It's 32. Okay, just round to the nearest whole number. 32, so neutrons would be 16. Okay. Chlorine, 37. We have an isotope of chlorine. Chlorine is generally 35 as the average atomic mass, but we have the chlorine 37. This is, again, neutral. We don't have any charges. So the proton number would be 17 for chlorine. Electron would be 17. And neutron would be 37 minus 17, so 20. Okay. Fluorine ion, anion. Okay, 1 minus charge. Fluorine is 9 on the periodic table. The atomic number is 9. It's a minus charge, so we have one more electron than normal. So we have 10 electrons, and the neutron number, fluorine's atomic mass is 19, so it will be 19 minus 9 protons, so 10. Okay. Calcium, 2 plus, so the cation for calcium. Calcium is 20, atomic number 20, so 20 protons. The mass is 40. Okay, so the neutron number will be 20 as well. Since it's a 2 plus cation, we have more protons than electrons. Remember, we can't add more protons, we have to take away electrons. So that means we only have 18 electrons. Manganese is 25 on the periodic table. Its atomic number is 25, so 25 protons. It's neutral right now, so 25 electrons. And manganese's atomic mass is 55, so the number of neutrons is 30. Okay. Barium, isotope of barium 139, atomic number is 56. It's neutral, so electron number 56, and neutron number would be 139 minus 56, so it'd be 3 and 8, 83 for the neutron. Iron 2 plus, so the cation for iron. Iron is 56 on the atomic periodic table, so 56 protons. It's 2 plus, so that's 2 more protons than as compared to electrons. So it's 54 electrons, and then neutron number would be the mass is 56. Wait, no. Iron is 26 protons. 24 electrons. Neutron is the mass number is 56, hence the neutron number would be 30.